Seventh graders, welcome to our Eclipse notes for this week. This follows more of the normal format that we're used to for class notes. I'm going to go through my slides. On your document there, you see that there are just 3 subheadings because there are only 3 slides of notes that you're required to copy down into that document today. So make sure that you're copying down all the bullets on those 3 slides as we get to them. You will also notice that the first slide the first heading for the first slide that says tides is a link. If you could please click on that link, watch the video. I didn't want to post it in here because it's a little bit longer, and so no need for me to do it where you could just go right to it and watch it. So pause this video, go to that document, click tides, that first subheading there on your notes document, watch the video about tides. It's the same guy that did the Eclipse video, so he talks fast. This is not an ed puzzle. It's not for a grade, but it's important for you to watch it because it's going to get you a better understanding about tides, why they happen, and some of the different types of tides they have, and why we have high tides, low tides, spring tides, and neap tides. Okay, so pause me, go watch that, and then come back. Okay, good. So let's go through tides. So I'm started off here, nothing for you guys to write down. I just have some pretty dramatic pictures of low tide versus high tide. And sometimes these low tides are and high tides are in the spring tide. And from the video that you just watched, you should know that a spring tide is when we have the highest of the high tides and the lowest of the low tides. So there's the biggest difference between tides is during a spring tide. So I know it's a little bit hard to see, but here's a house right here. Well, and here's that same house. And so right here, it's like this beautiful water area on this for this house. And over here, it's just kind of muddy and stuff because this is the low tide and that is the high tide. Okay, there's another one. You see that there's actually people walking down here through like some of the beach during the low tide. A high tide doesn't even look like there's anything there ever. Right? That's just completely covered in water during the high tide. This one even has a little walkway or a bridge across a little channel here of water. Well, during high tide, you can see that the channels, that walking bridge is completely covered. And if you're like, wait a minute, that doesn't even look kind of like the same spot again. I look for a couple landmarks. If you look back here, here's the same area back here, right? So obviously, if you are planting your stuff here for the day on the beach, you need to make sure you know when high tide is coming. Otherwise, you are going to lose all of your stuff. You might go out to lunch and come back and everything's gone because high tide comes in. Here's another dramatic one where it just kind of looks like all water, right? During high tide and low tide there. You have some beach, you have some mud. You can see kind of like these docks that come out. Completely covered in water over here. Okay, those boats aren't going anywhere during low tide, right? And there raises them up. So regular tides, high and low tides, can be pretty obvious to notice the difference. But sometimes when we have these spring tides, when it's even more dramatic, the pictures really, really show. Okay. All right, so don't worry about this slide at all. This is from past years when we were in class that you would take your book and I would have you go through and you define what tides is, what a spring tide is, what a neap tide is. You would explain why there are 2 high tides and 2 low tides every day. Then you would compare the size of high tides and low tides in a spring tide compared to a neap tide and know what causes the difference. We're still going to go through all that on our slides as we go through here, okay? There was the link to the video that you guys watched. Okay, so here we are. I want you to type here now under tides. In your document, under tides, go ahead and type in, the tides are the rise and fall of sea levels caused by the combined effects of the gravitational forces of the sun, the moon, and the rotation of the earth. As I go through this, guys, pause as you need to. Okay? I think it's most effective for you to be typing when I'm talking about whatever it is you're typing. So I'm going to kind of keep moving here through a pace that would be faster than class. Just pause the video, finish what you're typing, and then hit play again, okay? All right, so first of all, common question, if people would ask, what causes the ocean tides? Well, it would be gravity from the moon. That is true. But as you are seeing, the sun, the moon, and the rotation of the earth all have an effect on these tides. Okay? It is mostly the gravitational force of the moon that's pulling this water. But the other two, the rotation of the earth and the sun, also play into this effect. Like when we have spring tides. Okay? A spring tide is just after a full or new moon, where there is the greatest difference between high and low water. So think about the alignment of the sun, the moon, and the earth in a full moon situation and the phase of a new moon. They're all in a straight line. Hopefully, that is kind of giving you an understanding of, oh yeah, that would make sense why we have the biggest tide and the biggest difference of those tides when those all three are lined up, because those forces, the gravity of the sun and the gravity of the moon, are working in the same direction. So there's actually a little bit more gravitational force. It doesn't matter if they're in perfect alignment in terms of the axis of their revolutions, like it does for an eclipse. So if you think about it, that means that every time there's a full moon and every time there's a new moon, you have these spring tides. So you can have them almost twice a month, depending on the way the lunar cycle falls within a calendar. Neap tide. The Neap tide is just after, let me move myself. We'll go over here today. Just over the third quarter, okay? And or the first quarter, moon phase. And that has the least difference between the high and low water. And like I said in the videos, and again, what you should be thinking about of where the first quarter is and that last quarter is that they're at right angles, the sun, earth, and moon, right? They're at right angle. It's a right angle. And so they're actually pulling, the moon and the sun are pulling in different directions for the gravity. And so because of that, you have a little weaker tide because they're not working together. They're actually going in opposite. So now you're moving on to that next one, high and low tides, that next subheading on your document. Why do most coastal regions have 2 high tides and 2 low tides each day? So high tides occur on both sides of the earth closest to the moon, as well as the side farthest from the moon. Okay, so this has to do with the rotation of the earth. Okay, the rotation of the earth. So when you're at facing the closest of the moon, you'll have a high tide, and when you're on the opposite side, you'll have the second high tide. And that's again because of the alignment, right? You get kind of like this bulge, and they kind of not overstated it, but they dramatically showed you how that bulge kind of almost bulges the earth, and that's what pulls the water, right? Low tides occur then between the high tides due to the Earth's rotation. So it's about every 6 hours, right? About every 6 hours, you're going to change tides. Those of you that are familiar with going to the beach, especially with where there could be some dramatic high tides and low tides, and paying attention to those things, they usually have the times posted for you, whether it would be on a website, on the lifeguard stations. Sometimes they just have like a dry erase board where they write in when the high tides and the low tides are going to be, so that you're aware for the purposes of making sure that you don't lose your stuff on the beach or whatever it might be. Okay, now you're moving on to that third part, the last part here, spring and neap tides. It's the last subsection. So what is the difference between a spring tide to a neap tide? And we kind of already talked about that a little bit on that first slide. In a spring tide, the highest tides are at the very highest, and low tides are at the very lowest. Okay, that's what makes it a spring tide. A common mistake is people think, when it's a spring tide, that means there's high tides, and also the low tides are also higher than normal. That's not true. It's the biggest difference. So that means you have the highest high and the lowest lows in a spring tide. And again, it's because all three are lined up, the Earth, the Moon, and the Sun. For neap tides, your high tides are actually a little bit lower than normal, and the low tides are a little bit higher than normal. So the difference between those two is the least. It's the greatest during a spring tide, it's least during a neap tide. And again, now it's because the sun, the earth, and the moon are at right angles because it's first and third quarter phases of the moon. So the gravitational force is not acting together between the sun and the moon. They're acting in opposite directions. And so it's a weaker pull on that water. The difference is caused by the different positions of the earth, the moon, and the sun relative to each other. And I just went through and explained those. And they did it in the video. Now, when you get to the lab, okay, you're going to go through and you're going to see some of this stuff play out some more. So just kind of make sure you're paying attention to those differences between spring tide, neap tides, high tide, low tides, and recognize those differences here with some of these things. And you can hopefully start to see that bigger picture of how moon phases and eclipses and tides can all be put together here in one unit, because it is all about this relative position of the earth, the moon, and the sun. All right, good luck on the sim. There's a video on there to help you with that. This is it for the notes for this week.